Hello, my name is Cliff Schaefer. This is the first in a series of presentations about the OpenDSA eTextbook system. These presentations are part of C2Gen, a Chautauqua for the 21st century. Today I'll present an overview of the capabilities of the OpenDSA system. OpenDSA is an open source project to create a body of materials, initially for teaching data structures and algorithms courses. The fundamental presentation metaphor is as an online textbook, and you can get a sense of that by looking at this. You can see that we have a table of contents for the presentations that I'll be giving. So the fundamental metaphor is an online textbook. For any given course, a subset of the available materials will be collected together in the form of an OpenDSA textbook instance, which is what you're seeing here. And here's the URL if you want to look at this yourself in your browser. As you can see, this is set up as a series of chapters. I chose to make one chapter for each of the presentations. For the first lesson, I've selected some bits and pieces from available OpenDSA materials to show you. So let's get started. So the first thing I'll talk about is navigation. So you already saw that there was the table of contents, and so at the top of each page we have these navigation links, and this one would take me back to the contents, and this one would take me to whatever is the previous module, and this would be the next module. A module is one HTML page with whatever the developer wanted to put on that page. So the next is text content, so you can see some of that here. The authoring system that we use to create the content gives you all of the normal type of tools that you would expect, different fonts and links, and you can embed different things, sections and so on. But this has been tuned in particular for teaching the type of material that we want to present, which is mostly initially computer science courses. So you can see that there is support for displaying code snippets, and you can see those in different programming languages if this is available, if the different programming language snippets were available. And of course, when the book was configured and built, which languages to be displayed were part of that configuration. Math, this is done using LaTeX notation for the developer and then rendered onto the screen using one of the standard libraries. Right now we're using MathJax. You can see tables are done the same way. So the main things that are special about OpenDSA are visualizations and exercises. So the first example of a visualization is what we call an inline or embedded slideshow. And this form of visualization is typically just a static, particular example that someone developed. And there's not really much that a user can do other than just click on the buttons and see what happens. It's not intended to be interactive more than that. The next example of a visualization is intended to be interactive. In this case, to the extent that, first of all, you can start it and you can see an example, and I could do it again. You see that now I've got different values here. These values are being generated at random. If I wanted to, I can get in there and change the size. I could type in some numbers if I had a particular example that I wanted. But for now, we'll just take some random numbers, and this time an array of size 10. You'll notice it's generated a slideshow for those particular numbers. Here is the code. Of course, this is a visualization for a standard insertion sort. So we have the code here, we have a representation for the data, and here are the controls for the slideshow. Here is a little bit of text to go with each slide to tell the user what's going on. And you can see we can click through this and as I click, the pseudocode is being highlighted to show the current line, and a message is being given to show what's going on, and I can step through this and see what's happening. And at this point we can see that we've moving something to the left. We've now got the first 5 in order, and so on. As you can see, we have support in the system for generating visualizations and the text in different languages. There's not magic here. The translations have to have been provided by somebody, but it's relatively easy to do. There's just a file somewhere where there's a set of strings to define in whatever language you want to use, and then when we compile the book, we can say to compile the book in that language, or in this case you can see we just compiled a specific visualization in that language. So visualizations are good. We think the single most important aspect of our system is the exercises, and so there's a number of different types. Now, in this way this particular page was configured, the exercises are hidden behind these buttons. And let me mention that you'll see that some of these buttons are red and some of them are green. The green indicates I've already done it, so previously when I had been to this page I had worked through this particular exercise, so it's showing me that it's green. This one I haven't so far completed. This example is an exercise that was built using the Khan Academy exercise framework, and many of our exercises are, though not all of them are built using that particular tool. In this case I need to look at this tree and answer a question. This is a simple multiple choice question, but the Khan Academy exercise framework is quite flexible in terms of exercises that we can build. You'll notice that this exercise has in fact a visual component to it that was generated with our visualization software. So in this case, what is the height? See if I got, so you may notice that my count went up 1, and I need to do a certain number of these, and once I've gotten 8 points, this button will go green, and I will see that I have been given credit for completing that exercise. This is another example of again a Khan Academy framework was used to build this exercise, but this has a lot of custom support. The previous one was a simple multiple choice question. This one is an example of what we call a proficiency exercise, in that the user has to show that they understand how, in this case, an algorithm works by manipulating the array, and in this case they're supposed to be doing one iteration from an insertion sort. So in this case these two numbers would already be in sorted order, and I have to put this in sorted order. So I click here and I can see that if I think this is correct, then I can click and then it'll give me another one, and so I can do as many of these as I like, and when I think I'm correct I can click and oh no, I got that one wrong. And let's see, I could, if I knew what to do to fix this, I could, but I'm maybe not sure where I am at this point after having messed it up. So I can click the reset and it refreshes that. Oh yes, I can try it again. And if I feel I need some hints, then most of these exercises have a series of hints that I can look at. Here is an example of another form of proficiency exercise. This one happens not to have been built using the Khan Academy framework. Instead, this is using built-in support in our custom visualization library, which is called JSAV, for the JavaScript Algorithm Visualization Library, since it was written in JavaScript and it's for visualizing algorithm visualizations. In this case, I have to do something to manipulate this to show that I know how some algorithm works. In this case, I need to show what order things have been printed if I were doing an order traversal of this tree. And so if I were doing an in-order traversal, the first one would have been this node. Notice that in this case the score has gone up. I've gotten 1 of 9 steps correct. And if I continue through this, and I made a mistake. And the way this particular exercise is configured, if I make a mistake, it will correct it for me. I will lose a point, so it's not a free ride, and guessing isn't such a good plan if you want to get proficiency on these. But since it's corrected my mistake, it means I do have a chance of recovering and getting the rest of the points. Now maybe I've got the hang of it, and if I go through the rest of this, and at the done, I've gotten 8 out of 9. I've lost 1 point, and the way this was configured, 8 out of 9 was good enough to be given credit for this. And so if I were working through this in the form of a normal textbook, I would realize that I've completed that particular exercise. If I want, I can do another example. I can practice as many of these problem instances as I like, and I can also take a look at a slideshow that shows me how it should be done properly. Now, this particular instance I couldn't get credit for. If I hadn't already completed it, I would have to reset to do another one. No cheating by looking at the model answer and remembering it and going back and reproducing it. But I can do another one, and if I didn't have credit, I could do this one, and then I would get credit. We also have support for small programming exercises. So in this case, I would type in some code in here, and when I asked it to check the answer, if this were configured properly, it would go to our scoring server, which would sandbox the student code, check that it compiles, check that it passes the unit tests, would give feedback to the user as to whether they got it correct. If it didn't compile, they're told the compilation errors. If it did compile but it didn't run correctly, they're given some idea of what they need to do. You'll notice that there was a little bit of feedback in the sense that buttons turn green when you complete that activity. If I did all of the activities on here at the top, it would say module complete. There's also a gradebook here, and I can drill down and I can see that I have not completed this particular module, but I have completed these 2 exercises in this module. And hopefully that would guide me to go through and complete all of the activities. So that is our presentation for today. Thank you.